Benchmarking 101. So in this video I wanted to discuss, like I mentioned in the last video, a basic framework or a basic toolkit that you can acquire on how to run benchmarks and how to draw conclusions from the data, right? Like we discussed in the last video. So it's a bit complex. Basically, what's the purpose of benchmarking? Purpose of benchmarking is, let's say most cases it's maybe to compare two things, or to maybe like draw some conclusions out of some data, and helps you take the decision better, and let's say understand the edge cases where things might break, which one would be better for which use case, what fits in your requirements, etc., right? So it's very important in making decisions, and that's one point of understanding. The second point that it makes sense to know benchmarking is so that you make whatever you decide whenever you're building something, you make it from a point of awareness, like, okay, so I understand this, I'm going to use this, but later when we reach XYZ and so on, this issue might come up, and that you are aware because you ran some benchmarks initially, rather than, let's say, relying on someone's advice on they taught you to use this, or they asked you to use this, or whatever, right? So basically it's an evidence-based approach that you can take to decide which one to use, which one not, like what not to use and when to use it, right? So let's get started. So it's I didn't even count 1 2 3 4 5 6 7-step thing for now. In this video I'll just go through the steps one by one. In the next video we'll understand some metrics that we might want to track for basic benchmarking. Like, this is very generalized video, like the next 2-3 videos will be very generalized ones, and the metrics can get specific, but that should do it for most of your use cases, like the ones that we'll discuss. So yeah, so let's get started. So benchmarking 101, the first step is isolated environment. So you see, like when you are running benchmarking on a device that is not isolated as in there are 1,000 processes running in the background, that might affect whatever results you ultimately get from that benchmarks. So like the things are very sensitive. So it depends if you want it depends on a use case to be specific, if you would want an isolated environment, or if you can, like, if you are okay with the noise, because if it's not very sensitive operation, if you are making some general purpose conclusions and assumptions and stuff, then I think you can still do that without having an isolated environment. But let's say you the stakes are high and you need very accurate benchmarks and very accurate numbers and all, then I suggest you go for an isolated environment. It can be like some Linux instance in some cloud environment where minimal amount of things are running, which won't interfere with whatever benchmark you're trying to run, right? So yeah, that's the first thing. The second thing that comes up is a warm-up period. So what's the warm-up period? So when you start a process, let's say we're starting something in JavaScript, the JIT compiler takes a while to jumpstart and get in the flow, to bring in the efficient stuff that it does for compilations and stuff, right? So those are out of the scope, but basically it needs a while to get in the zone, if you may, like. So that's the warm-up period. So let's say you are running some test in some 10,000 iterations, or maybe some like 100,000 iterations, and let's say you put the first 2,000 and so on iterations for the JIT compiler to get warm up, specific to JavaScript. It can be for anything else as well, since it's a JavaScript series of videos, so I'm mentioning JIT or anything as such, right? So just so that it can get in the flow and you can get some accurate benchmarks, so we need a warm-up period for that. The third thing is consistent state, right? So what does consistent state mean? Consistent state is basically, let's say you are comparing two things, right? So when you compare two things, let's say the input, the amount of input that you are putting, and whatever state of input that you are putting in one, that should be consistent across the others as well, right? So that, let's say you are comparing two things by keeping one as constant, then you can again compare something else by keeping the others like something else as constant, because then you can accurately see. Let's say if we are talking about 2 dimensions, let's say, since we are comparing x and y, keeping z constant or something as such, right? So you basically when it comes to specific to like coding benchmarking, you can say, let's say, most of the time we keep the input state constant, and there might be some other factors, but that will cover most of the use cases. Let's say whatever input state you're starting the test in, it's better. Like it again also goes back to isolated environment. Let's say some process that was running in the first iteration stopped in the second iteration, which might affect your benchmarks, but that again depends on how sensitive or what stakes are involved in whatever numbers you get out of that, right? So for simplicity, let's consider consistent state to be whatever input you are putting, and the other things you can decide based on what level of numbers or what level of accuracy you want. So that's the consistent state. And then we have repeat trials. This repeat trials is sort of to mitigate the non-isolated environment effect. Let's say you get some number in one trial. So whatever videos we've been doing till now, we have run like 5 to 6 inputs, but those are not very those are not very useful when you want to draw some conclusions out of it, like at which point it breaks, or might be some other process running on the background that might have affected it, right? So repeat trials, as in you run multiple trials of the same thing, and based on that you get more accurate results, not the absolute one, like more accurate as in more accurate than running less trials, because you have more data, so you have more data points to make the conclusion out of. But if you do the same for, let's say, 5 to 6 iterations or 5 to 6 trials, you might not get some insights which you might get while doing repeat trials, since you have more data to rely on, right, and make conclusions from. So that's why repeat trials is important. So something that didn't come up this time might come up next time. Something that might not come up next time might come up the next time, and so on. So that's the concept behind repeat trials, right? The next thing that we have is reliable timers. So this is a very important thing. So let's say the accuracy of the timer also depends. So if you would have noticed, I use like in the earlier videos, whenever I had to calculate memory or time taken, I use performance.now. So the accuracy there matters. I could have used new date as well, but since we are calculating in milliseconds sort of a parameter, the accuracy that comes up from performance.now is more accurate than what comes from date.now. That's just an example. You can like translate it to anywhere that you want. So the timers should be timers that you use should be reliable. Let's say I have a stopwatch and it measures only in hours, and I have something that I want to do a benchmark that involves data changes in milliseconds, for example. So even if you start the stopwatch and measure the data, it will always show less than 1 hour, 0 or whatever, right? So it's not reliable. So that's the concept behind reliable timers. The accuracy of the timers you use should match with the accuracy of like the average sort of a range of whatever benchmark you are trying to make, right? So that's the purpose of reliable timers. The next thing is statistical analysis. If you when I was in school, it was like the most hated subject, but maybe it wasn't taught well, but it's very important. Like statistical analysis, at least the basic metrics, whatever metrics we get, like we get the data, we plot the graphs and we get the patterns and all, then we need to make sense out of it, right? So for that, there are some metrics that would help us in making sense out of it. The basic ones, mean, median, standard deviation, and so on, right? So those are the basic ones, and you can go on to depth. There are other factors which also take into consideration the environment, and is the results reliable, whatever external noise might have affected the study and all, right? So those are important metrics for you to draw conclusions, and based on the sensitivity of the test that you are trying to run, you can explore as many metrics as you want. But normally these three does it, mean, median, standard deviation, does the job well for general purpose things, right? And at last we have conclusion. So we have everything. We ran repeat trials, we use reliable timers, we have all the statistical metrics. Now what to do with those, right? How to make sense out of it, and how to translate that to a real world use case. That comes up in conclusion. We have to make sense of the data from whatever metrics we track or whatever pattern we get from the graph and so on, right? So yeah, that comes in conclusion. And in the next video, I'm thinking of discussing statistical analysis, like basically some basic benchmarks or some basic metrics that we would need to calculate. And after that, we'll do some 2 to 3 comparisons and like try to train that muscle of, let's say, how to draw conclusions and how to make sense of like patterns and stuff that we see, right? Rather than relying on XYZ person said it, you can just measure it yourself and see it for yourself, which one is more efficient or which approach to take or where it might break, right? And what trade-off makes sense for you. Cool. Yeah, and that should be it for this video, guys. So if you like the video, maybe share it with your friends who might find it helpful. And if you are new here, maybe please subscribe. And if you have any suggestions or if you want me to make videos on something else, please leave a comment. You can find my socials in the bio. And yeah, see you folks. Bye.